Okay, hello, welcome to my channel. Now in this video, we want to find the integral, alright, from 0 to 1 of the natural logarithm of 1 plus x divided by 1 plus the square of x, alright. So this is a really hard integral if you don't know how to start, alright. And even if you do, there is a tricky substitution that we are going to be doing, and I'm going to tell you a little bit about it. All right. Okay. So first of all, we recognize that we have the sum of squares in the bottom. So in fact, we want to make use of the tangent substitution. All right. So when we have 1 plus x squared, or maybe a perfect square plus the square of x, or a square of a linear function of x like this, the tangent substitution could be a better way to start. All right. So let's just start off by saying let make x to be, let's call it just tangent of an angle, right? Let's call it theta. Then the next thing is to differentiate that, right? So we say the derivative of that will give us, when we differentiate tangent of an angle, we have secant squared of that same angle, right? This is just an identity function inside, so the chain rule is not needed here. So we can put the d theta over here. Okay, so you notice that the next thing we'd like to do is to look at the bounds of integration. So let's see. This is going to be the integral from, well, when x is 0, tangent of an angle gives us 0. That angle can be 0, right? Let's just make use of the principal angle. Okay, so when tangent of an angle gives us, when the tangent of an angle gives us 1, this angle, the principal result can just be pi over 4, right? That is 45 degrees. Okay, great. So this becomes the natural logarithm of 1 plus the tangent of theta, right? So we'll put it down here, 1 plus tangent of theta, okay, and then we put it divided by, well, 1 plus tangent squared of an angle. You know, x is tangent squared of theta. So 1 plus that will just give us secant squared, right, just by trigonometric identities. Then the dx, well, the dx is already secant squared of theta d theta, right? So you put it down, is secant squared of theta d theta. So as you can see, this and that will cancel, right? So that means we are going to have the integral from 0 to pi over 4 of just the natural logarithm of 1 plus tangent of theta, right? So let me just put it down here, tangent of theta, and then the d theta over here. Okay, that's nice. Now I would like to make a substitution. This is where we have the tricky stuff we want to do, right? So let me just see. Okay, so I will make a substitution such that these bounds of integration will be changed or will be overturned, right? Just this one will come here, and then the pi over 4 will go down to where the 0 was. And that is just by negating your input. So I'll start off by saying let's make a substitution. Let's use maybe another variable. Let's say t. Let it be pi over 4 plus 0 minus the input, which is theta. So that will be pi over 4 plus 0. That is just pi over 4 minus theta, right? So notice that when theta is 0, t will be pi over 4 minus 0, which is just pi over 4. And when theta is pi over 4, t will be 0. Isn't that very nice? But let's differentiate this first. So the derivative of t with respect to theta will be, that will just be negative d theta, right? Because this right here is just a constant. Okay, so that means this will become, the integral, remember what I said, from pi over 4 to 0 of the natural logarithm of 1 plus tangent of, right? So in place of theta, we are going to put in, now notice this is t equals to pi over 4 minus theta. Therefore, theta will be pi over 4 minus t, all right? So pi over 4 minus t, just by making theta the subject of formula. And then the theta, we can replace it with negative dt, all right? So let me just put the dt over here, and then maybe put the negative out front. Okay, that's nice. But look at this. This is a negative, all right? Just minus 1 multiplied by the integral. It can help us to change the bounds of integration back to what it was before. That will be from 0 to pi over 4, right? Because when you multiply the integral by a negative sign, this is something as changing the bounds of integration. Okay, very nice, isn't it? Now look at this. This is 1 plus. Now, tangent of the sum or difference of two angles, right? We are going to apply that here. We are going to have tangent of the first minus tangent of the second divided by, so let me just putting it down, tangent of pi over 4. In fact, tangent of pi over 4 is just 1. So we say 1 minus tangent of t, all right? Okay, we divide it by 1 plus, because this place is minus, When here is minus, we'll put the minus at the top, the bottom will become plus. Then the product of the tangent of those two angles, that will be tangent of pi over 4, which is 1, times tangent of t, which will just be tangent of t, right? So we have that, and then we can put the dt over here. Okay, that's nice. Now let's add these fractions together and see what we have. So this will be the integral from 0 to pi over 4 of the natural logarithm of, well, this is when we multiply this with that just to balance the denominators and the rest. We are going to enter with 1 plus 1 will be 2. Then positive tangent of t minus tangent of t, that will just be 0. So we have 2 over that. That is the denominator, which is 1 plus this tangent of t, right? So just add the fractions, and this is what you are going to have. Okay, so this looks harder, you know, this place. If we should make a Weierstrass substitution, no. But here, in fact, we can apply the logarithmic properties. Nothing, this is the natural logarithm. The natural logarithm tells us that when we have the input as a fraction, we can split it into the difference of the logarithms of those two parts. So that's going to be the integral from 0 to pi over 4 of the natural logarithm of the numerator, which is 2 in this case, right? We say minus the natural logarithm of the denominator, which is 1 plus tangent of t, right? And then we can put the dt over here. And we'd like to put this bracket so to show everything is in there, but I mean, if it is there, it is there. It doesn't really matter, right? Okay, just for you to be careful. So what I'd like to do is to split the integrals into two, given that the integral of the difference of two functions is the difference of the integrals of those two functions. So that will give us the integral from 0 to pi over 4 of this constant term. In fact, this will become natural logarithm of 2 times pi over 4. All right, so when we integrate this over the t variable, we'll just have t times this. So from pi over 4 to 0, we will put that in. You're going to have that, and then we're going to take this integral from 0 to pi over 4 of this input, which is natural logarithm of 1 plus the tangent of t. All right, and we put the dt over here. Now take note of this term here, negative of that. Now the essence of this substitution is to help us to get something very nice. Look at this. Look at this term here. Before we made the substitution, right? Maybe if I call this I, maybe I1. Notice that I1 is now equal to the sum of the difference of these two parts, this part and this part. Now, in fact, let me clean this from here to here, right? So that you can see what I'm going to talk about real quick. Okay, so you notice that integrating this, all right, we got here, which I've written out here, right? So the integral from 0 to pi over 4 of that is the same thing as this and minus that. Now I want you to take note of these two integrals, this part and this part, right? Notice this equality sign. Now, this is from 0 to pi over 4 and this is from 0 to pi over 4. This is exact same function as this, just that the variable has been changed. This is in terms of theta while this is in terms of t. In fact, this is a definite integral, and these bounds of integrations are just numbers, meaning that the result will give us just a number. So in fact, the variable here are called dummy variables, all right? Doesn't matter what they are. If they are theta, I can change them to t as much as I want. Whatever they are, I can change them to whatever I want. It does not change the result of the integral because these are just dummy variables. So because of that, I would like to change this thing from t to theta. All right, it's just the same thing. Then I change this from t to theta. So what do you see? Well, we have the integral of this is equal to something minus itself. So to achieve the actual thing, we need to add this to both sides. When we add that, we're going to have 2 times of the integral from 0 to pi over 4 of the same input. And that will just give us just this part only. That is the natural logarithm of 2, then times pi over 4. So to achieve this integral, right, that is the I part, we need to divide both sides by 2. So dividing both sides by 2, divide this by 2, and then divide this by 2, right? So all in all, we are going to enter with the natural logarithm of this, that will be pi over 8 times the natural logarithm of 2 as the result, right? So you just see that is just pi over 8 times the natural logarithm of 2 just by dividing both sides by 2. All right, great. Okay, thanks for watching, and please do want to subscribe to my channel and share this video with your friends, all right? Okay.